Hi, Sierra. I think I finally figured something out in terms of this question. Sorry, my internet, we got a new modem, and so we've been setting up our internet all night, and so I couldn't use it. But I found an old textbook, and it has, I think, the exact same thing. What we're making is an orthogonal basis. And so, what we need to do in order to find that third vector is we need to find vectors u1, u2, and u3 out of that set. And here's how it goes. u1 is equal to vector w1. So in other words, the first vector just stays the same. The second vector is the projection. It's w2. So it's the second vector. So w2 is v. So this is v really. Minus u times w2 over u dot u. So those are dot products, okay? So that's the same as what you had, like the projection, v minus the projection, okay? And then multiply that by vector u. So vector u2 is going to be really v minus u dot v over, that should be the u there, sorry. Just erase that. Oh, shoot. Okay. So that should be u dot u, sorry, just like your formula. Okay, so that's all the same, but that's how you find vector u2. So that's your second vector for the orthogonal basis. And then what happens is that third vector that you're trying to modify, you were on the right track. It's the third vector in your set that you were given. That's what w3 is, minus vector u times the third vector, which is your w, right, over u dot u, and all of that multiplied by u, minus vector v, no, sorry, that's where we go wrong, vector u2, which is the result that you got in the second line, times dot product w3, so the third vector, this is vector w, over u2 times u2, and so that's u2 dot u2, which is the resultant vector that you got right here. Okay, so that's different than what we did, and then you're going to multiply that by that answer as well. So that's how you set up your basis. It's an orthogonal basis, u1, u2, u3, and that's how you get the three vectors that go in it. So they didn't ask you to change the second vector, but they did ask you to find the third vector, and in order to do that, you have to modify the second vector, if that makes any sense. So when you do this, u1 is going to stay the same, but u2 is going to be different, and so u2 is going to be the original second vector, which was 1 minus 1, 0. And then we're going to take away the first vector, the dot product of the first vector with v, so the dot product of u and v. And so in this case, that's 1 plus 0 plus 0 over the magnitude of u dot u, which is 2. We're going to multiply that by vector u1, which is the 1, 0, minus 1. And then the result that we get there is actually going to give us vector u2, and we need that to do the third vector. So I get 1 minus 1/2 for the first component. I get minus 1 minus 0, so that's going to be minus 1. And then I get 0 minus minus 1/2, so it's going to be plus 1/2. And that's going to give me my vector u2. And that's what I need for the third vector, okay? So for the third vector, let's do this in a different color, u3 equals the original vector that they gave us for w, which is 0, 1, minus 1, minus u dot w3, which is really the original vector, the first vector, u times w. We're going to do the dot product there, so we should get 0 plus 1 over, it's still over u dot u, which is 2, isn't it? And times that by the first vector, 1, 0, minus 1. And then we're going to go minus, and we're going to bring this part into it. So we have u2, which we just found, right, which is this one here, dot product with w. So dot product with w would be 0 plus minus 1 plus minus 1/2, so minus 3/2. And that's over u2 dot u2. So that's this vector, u2 dot u2, so that's going to be 1/2 times 1/2, which is 1/4, plus -1 times -1, which is 1, plus 1/2 times 1/2. So we have 2/4 plus 1, 6/4, or 3/2. Now in the top, was it negative or was it positive when we did the dot product? We had u2 times w, and so we would have had 0 and minus 1 and minus, so that should have been a negative there, sorry. So that's going to give us the minus 1, and then we're going to multiply that by that vector from right above us there. Okay. So this is a long video. Let's go down here. We get 0, 1, minus 1. Then we get minus 1/2, 0, minus 1/2. Then we get, this whole thing here is minus 1, right? So it's really minus times minus 1s, which is really like plus 1 times 1/2 times minus 1 times 1/2. Okay, so what happens when we add all this up? We get 0 minus 1/2 plus 1/2. So the first one is 0. We get 1 minus 2 is -1, plus -1 is -2. Oh, that's a 0. Sorry, 1 minus 0, that's the second component, is 1, and then minus 1. It's going to give us 0 again. And then minus 1 minus -1/2, so minus 1 plus 1/2, which is minus 1/2, and then plus 1/2, oh, 0 again. So the 0 vector is the only vector that's going to be orthogonal to both, according to what I've got here. Obviously, if you do dot product of that with the first two, we will get 0, and it appears that that's the only one that will work. So that's my answer, and that's taken from a textbook, an old textbook, but where it lays out how to find the orthogonal basis, where you're trying to find a third vector that's orthogonal to the first two. So I'm pretty sure that's what we need to do here. I hope that helps. All right. Good luck.